Quote for today is, our knowledge begins with the senses, proceeds then to the understanding, and ends with reason. As we go on in the course, I think everybody knows we're going to end up going through from the world around us to the senses, to understanding that, and to reason. Today we're going to be focused on the senses. And that's why I picked this quote, because if you're a firm believer in the importance of understanding and reason, you'll understand as we go along, if you don't already, that the senses are a really important part of our understanding. We saw an example of that last time in class. You'll see more examples as the classes continue. The important announcement. I mentioned that we might have some classes that are done online, and that's going to happen on Wednesday. So this Wednesday, at the exact same time that the class is going on, I'll be giving this class live, but online. There's a little chat box in this. If you haven't used it before, I would encourage you to go make sure you can use it before the class. And that's Zoom. So here's the link here. Zoom. Has anybody used this already? Some nodding heads. Okay. So at that time, if you put this in, you can actually do it. I've done it from my cell phone. You can do it from my tablet. You can do it from my computer. Most important, have some headphones on or something so you can hear, because I'll be giving the class just like I am now. If you've seen the class online, that's what it's going to look like, except there is a chat window that I'll figure out how to use before then and there. So you can ask questions, and I'll be able to ask questions. And I'll be taking 10 minutes based on the fact that you're going to show up there and come in. So I'll see everybody that's on there. I'll keep screenshotting that. And then if I ask questions of the class and no one answers, I'll assume no one's actually there and they're all doing that. Okay, so very important. I apologize for doing that. I'm a very open person. I believe it's extremely important in life. My mom happens to not be feeling well. She's been not feeling well for a while. And she had to go to the emergency room yesterday. She lives in Texas. So I'm going to fly out there tomorrow. And as much as I'd like to be back here on Wednesday, logistically, that probably doesn't make a lot of sense. But I will be giving a class at this time on Wednesday. So you shouldn't have to adjust your schedule other than to figure out a good place. And I don't care where you do it from, but just a good place to be able to focus on materials in the class. Okay? I won't have office hours on Wednesday because I'll be gone. But I'll have virtual office hours anytime you want to send a note. It looks like I've been getting good notifications when someone does put something on Piazza. So that's the best place to ask your questions. I would encourage you to do it ahead of time. The homework's still due, just like it was before Wednesday at 11:59 p.m. So, any questions about that? If you don't have that link, you'll be able to get these slides on the internet, but I'll also put it on Piazza at some point. So you'll be able to get it there. Okay, so we decided that this very simplistic model was going to help us understand humans, and a lot of the topics in the course build on this model. And I wish I could get rid of this top ribbon. And it's gone. Okay. So last time we talked about reality, and really reality, we said, is the environment and things that happen within that environment, what we call occurrences. So the environment is reality, that's here at the top. Our representations of the observable environment is what we think of as reality. So when we perceive something, we create a reality. That reality exists only in our own minds. Everyone else's reality is different. And we have those realities, which are representations, knowledge, and reasoning. This is our realities here that we create by observing our environment through our sensors. And we're going to talk about each of those sensors so that you can understand how they work and what they sense and what they don't sense. And we're going to contrast that to artificial sensors and what they sense and what they don't sense. And the good news is for the majority of sensors, it actually turns out if we want to construct an artificial system that we have a lot of advantages in artificial systems than we do in real systems. So today you're going to see that as good as we think our hearing is, or as good as we think our vision is, it's pretty horrible, in fact, when you consider just how much stuff there is that's going on sonically and how much stuff there is that's going on in the electromagnetic spectrum that we actually can't see and we can't hear. Okay? So as we build artificial intelligence systems that have general intelligence, we may have some advantages in terms that we can build systems that can hear better than we can hear and can see better than we can see. Okay? So remember, we observe reality and we create these realities, and the realities are things that exist. Whether we know they exist or not, they're real, they exist somewhere. Things that happen, and those things that happen independently of our observations. And we sense these things passively or actively. Most of the examples I'm going to give you are of passive sensing. That means that whatever is happening, the energy from whatever happens goes through our senses, and we analyze that and interpret that in some way. Passive sensing means that you or someone does something and listens for looks for a response. So that's what active sensing is. An example of that you'll see a little bit later is that of a bat, which makes noises at night that it can hear in order to figure out where it is and what's around it. All right, so now we get to go one click down from our environment to sensors. Today I'm going to talk about what is sensible, meaning what's available that we can actually sense. And you're going to help me here because it turns out, very simply, there's only actually 5 things that can be sensed. And if I'm missing one, you're going to help me figure out what the 6th one is, but I think there's only 5. So we're going to see what are those 5 things that can be sensed. We have sensors, and they are human sensors, and we're going to go through what those human sensors are and how they can sense things that are sensible. We'll describe what the limitations are. We'll see that we can only sense a little bit of actually what's out there. So our reality, what we think is our ability to assess whether something's real or not, is based on only being able to observe a little bit about it. We'll compare our senses to non-humans to see in what cases animals, for example, have better senses than we do, or their senses aren't as good. So what's their perception of the world? It's different than ours. And we already talked a little bit about passive and active sensing. I would like to get to sound today. It's a little aggressive when I cover all the slides that I have and some of the demos that I wanted to show. We'll just see if we get there. If not, we'll pick up at sound. If not, we'll go partially through sound because I want to make sure we stay with the syllabus in the course and don't get behind. Sensing we do with our organs, and we sense these 6 things, or we sense things related to these sensors that we have, if you will. Sight, we hear, we smell, we taste, we touch, and one that a lot of people aren't as familiar with is we sense things about what are going on inside the body, inside our own bodies. That's called interoceptors. A good sign of interoception is if you're sensing something that someone else is not able to sense. You're sensing something that's going on inside. You're sensing if you have to go to the bathroom. You're sensing if your stomach doesn't feel good. Those are the types of things that you sense there with your organs inside your body. Okay. All right, this is going to be a little interactive, and I had thought I was going to have a little stick with all of your names, but little sticks with your names on it. Because my wife, who was a teacher for 20 years, wanted to make sure that everyone in class was participating. I told her that the class is participating, they're always offering things and asking questions. So that's going to happen not this Wednesday, because it'll be virtual, but at some point I'll bring those in. I guess the way it works is that when you ask a question or make a comment, you get your name stick. And so then I make sure that everybody at some point has done that. Okay. So now we're going to practice pretend you have these sticks, although it's not going to count. So imagine a person who was born without senses, without any of their senses, without any of these 6 senses of any kind. So they don't have the ability to sense anything outside themselves, and they don't have the ability to sense anything inside themselves. They still have a brain, brain's functioning, just things aren't going inputted into the brain from any sensors. So simplistic way to think about that is we know there are people who are blind, who can't see. Some of them are blind from birth, some of them become blind after. We know there are people that can't hear. You probably know, or you may have heard, that people who can't see tend to develop better hearing, or people who can't hear tend to develop increase the ability of their other senses, smell and taste. So you can exist and lead a perfectly productive and happy life if you're missing one of your senses. And you can do that if you're missing 2 of your senses. Okay, so it's a little bit of a mental exercise that says, okay, let's just imagine you didn't have any senses. Okay? Would such a person that was born with no senses know that they exist?
Let's say no, so they don't receive any input, nothing at all. So they I would think they wouldn't even move or do anything. They would basically be like an empty shell. That's what it would.
Presumably, if they did move, they wouldn't know they were moving. Presumably, right?
Well, since they don't have internal senses, they don't know they're moving.
What do you think?
Well, I think it depends on your school of thought. This is a very, very important question.
I don't know the answer to the question.
I don't think anyone does. Right?
But what we're doing here, and just, because I don't want anybody to feel uncomfortable, we're not trying to answer secrets of the universe. Right? We're trying to understand how our senses, the role our senses play in that chain down through the model to our own perception of the world outside of us and our perception of the world inside. But,
So a prominent saying in school of thought would be, I think, therefore I am, right? But thinking isn't really one of the senses, or is it? So then that leads to even more questions about what existence is and how we perceive that.
yes.
So this is obviously an impossible question also to answer, but could this person dream? If this person can dream, then they'll know they exist, because there's also been said that people without sight ever have been able to dream and visually see things. And that brain, you said, is still working, so by being active regardless of it. Well, another question: does fear count as an interoception?
That touches into a different topic, which we'll get into a little bit. so I'll defer that. Let me address your second comment first, which is going to be a total deferral. I'm going to kick it down the road, which is that there's a strong relationship between your internal senses and emotions, and fear being an emotion. So there are some questions about that that actually we're going to get to very, very, very quickly. The first question about whether or not you can dream, it's a good question, right? Because in our dreams, we do incorporate a lot of things that we have seen or things that we have heard. But we also see a lot of things in our dreams, at least I see in my dreams, that I haven't seen. Maybe they're combinations of other things. So I don't know the answer to your question, but certainly the dreams would be different, right? And a lot of our dreams that tend to incorporate things that we borrow from our observations of the world.
Yeah. Another thing about that is like humans that tend to stray away from being to be sociable, like lose a lot of like other animals know certain things as soon as they're born. How this person should have some like innate, like, born like just from birth things that would make him or understand that they exist.
Yeah, it's very good. When I first saw it, well, before they were born, they had like babies, they play music sometimes. So the baby can begin singing. Now, I don't know, honestly, whether or not, I just don't know, maybe you can look this up, whether or not the music's actually going through their ears or if it's just being sensed through their bodies and vibrations that are coupling the sound. But in this person, the idea is that whether they were born or not, they still wouldn't be able to sense that. So it definitely would get to the question of what's in your brain when you're formed, right? That it's sort of like what comes on your PC when you buy it at the store. What's on the hard drive already? What applications are on the hard drive? So, yes.
I think that the unique thing that person can do is to recognize their own existence, because they don't have other way, because without any senses, the unique way that they can manifest their own essence is going in terms of and making their own conceptual structures, making connecting all these links that only sees the inner inside of them. So that will be the only way that they could acknowledge their existence.
Yes.
I think such a person couldn't know they exist, because if you're born without any senses, you wouldn't be able to learn social skills, learn language, which has been recently thought to be crucial to like your inner monologue. So if you don't know any language, you can't frame your thoughts. And if you can't frame your thoughts, why is that your monologue? You can't know or like form an idea that you exist, and you just be the reactionary man, essentially. If you can sense something.
Yes, that's a good point. So whatever thoughts, presumably the brain is functioning, the brain is functioning fine. Right? That's the idea in this thought experiment. So to the extent that the brain comes with something in it already, then presumably that information is going to be accessible to whatever the processes are. Then you would expect that if it's a healthy individual, to the extent that the person could be without their senses, that the brain would be doing something. It would be doing something with the information inside, but it would be something that's very different than what we're doing. We're going to have a few more of these, so I'll take one more and then we'll keep going. There's about 4 of these questions.
I don't know if what it means to exist, because if he is dreaming, he would know he exists in the dream. He wouldn't know he exists in our existence, in the real world. We like the virtual reality world.
Mm-hmm.
So he could exist, but he wouldn't know he exists here. He's never perceived anything around him, pain or.
Right, and the one thing that's missing in that environment, presumably, is that there's no feedback. Right? We have the ability to see something, and we have the ability to touch it. If you look at babies, they tend to let them touch things and put them in their mouths. Right? And so there's a lot of feedback that they're getting, which presumably helps them make sense of whatever is going on, whatever they're going into the ears, whatever is going into their eyes. So the question is, to the extent that you don't have the ability to feedback, how would you know? Presumably, if you could move, you would touch something, but you wouldn't feel it, right? So you'd be sending a signal to your arms and it would move, but it wouldn't matter if you were moving it in the air or moving it against the wall. You wouldn't feel anything different. So a lot of the feedback that we get that tells us that we're real and that this nasty is here, that it's actually there, is important as we develop an understanding of the things that we do sense. So I'll put another one here. Before I do, the question, I started this question a little bit with a question for a reason. I said, okay, if we have all our senses, then and our brains function properly, then we know we exist. It seems to be something that everybody acknowledges for themselves. If we said if we lose one sense, right, then that's pretty clear. But somewhere from having our 6 senses to having no senses, it becomes a little murky. So then we can back up the question and say, what if I had just one sense? If I was going to be born with no senses, but the last minute, they asked my mom or something to say, hey, we'll give them one. Which one? And would it make a difference for this question? Would such a person experience emotion?
With no senses?
With no senses. That one's hard to imagine. I don't know the answer to this question. But if you wanted to make sure someone would experience emotions, you can give them 6 senses, right? You can take one away, let's take away sight. They would still experience emotions. You could take away taste, but they still experience probably. Is it one of those senses that's particularly important? Or do you have to have more than one, or do you have to have 2 senses to experience emotions? You have to have 2 senses to know that you exist. Presumably, if you could experience taste, and you had no other senses, and someone put sugar in your tongue or something else, presumably that would activate things in your brain, and yes.
I would think that it would just be only emotions, just as he said that there's not a framework to actually form your thoughts clearly. Then it'd just be a way of just the brain would still be working, and it would be constantly receiving, let's say, chemicals and stuff that would affect your emotions in some way, but there wouldn't be a certain description of just feel it and I don't know.
So maybe similar emotions to what we experience, but we would have no way to, that person would have no way to categorize that emotion.
Yeah.
Any other comments on that? So that was the other question. How many senses are necessary to experience emotions? This is the subject of our course. It's really super important, right? Because if we're trying to create something that has artificial general intelligence, we don't necessarily need to create what a human is or what a human can do, but we need to understand what of a human allows that human to be artificial I'm sorry, not artificial, actually general intelligence. So could a person exhibit general intelligence if they have no senses? Yeah.
If he doesn't have any senses or if he doesn't get any feedback, then how would he generate actual general intelligence? That's a question that's very redundant, I think, well, very hard to answer.
Very hard to answer. Yes.
I see it more as a security issue we have with existing artificial intelligence systems. That if you can have sensors and stuff, that you take all of that out of the current systems, it will be able to actually actual rational decisions, because it wouldn't have any kind of sense. It wouldn't have like parameters that it would have any kind of input or feedback to actually say, all right, I'm going to do this because this. So I see more of a like that's segregation. So if a person, at least in my opinion, if a person doesn't have any kind of senses, it wouldn't be able to exhibit any actual like general intelligence, or at least have a complete framework of how general intelligence works.
Even though it wouldn't, I don't think the person will be able to exhibit any intelligence if it doesn't have any complete senses. But looking at it as an actual artificial intelligence, the person and the artificial intelligence would be able to have its own thought if we give it some senses. We would be able to teach it and it would be able to memorize and learn. Yes, it will be using human brain or architecture that is the word name as a human brain. So it would be like the baby version of artificial intelligence. It's just implemented, but doesn't have any. You haven't given it any action.
So there's a lot of what you said. The key thing I want to emphasize is learning. So we learn through our senses because we're not, even if we are born with some innate knowledge, what we would consider to be intelligence or general intelligence requires learning. So if you don't have your senses, then it's pretty hard to learn. One more here, and this maybe should say which ones. Okay, so if we started to pick, right, for your own selves, and it's a little bit hard to answer this question because all of you have had senses for a long time, right? You're sitting here today after almost a couple of decades, or around a couple of decades of existence. And so these questions are aimed at what if you never had them. But how many senses, or maybe a better question is which senses do you have to have for artificial general intelligence? And now let me remove the artificial general intelligence just for general intelligence. Just one. Which one?
Doesn't matter. It would be like different kinds of general intelligence, but well, maybe not even general, just like different kinds.
So I think what you're saying is you would have some intelligence, but maybe in a definition where general intelligence means that you're able to have thoughts and exhibit behaviors that are would be sort of characteristic of a typical human being. That might be hard.
Not really, because if you see something, then you watch like how others behave, and if you like depending on what you hear, and like if it's a loud noise, you will know it's not good for you. Then you try to avoid that. And if it's something pleasant, then supports it. As
How
for-
do you communicate that? Let's take this for a second. So let's say you could only see, and that's all you could do for a reason.
So if you see someone doing something that's pleasant, that looks appealing, you try to do that. If you see someone that touches the stove and you see that their reaction is negative, and you try to not do what that person did.
How would you know if their reaction is negative?
Well, one example would be that watch or see someone dying, you know, that's not good. For as graphic examples, it gets more complicated.
I'm not trying to put you on something.
No.
I don't know the answer to these questions. But probing these is important in terms of understanding what we need to focus on when we create something that we want to start approaching generally. So I'll take one more and then we're going to go to the next slide.
I think it's minimum of 2, because for general intelligence, you need cognitive ability. For cognitive ability, it needs various mental activities. So just having one, it's not varied at all. It's just specific to that. So if I were to pick, it'd be most important, like it would be sight, touch, or hearing touch.
It's very interesting because if you look at computing systems, they're really, to the extent that they sense. I think people would suggest that sight and sound are actually pretty good. The artificial system can capture sounds, and now you can interpret sounds. So in vision, you interpret a little bit vision in terms of some of the other senses. I think we're part of. Okay, so the point of that, I think, was to have us explore some of these questions, and now we'll get to what is sensible. So I'm going to make a strong statement here and say that these are the only 5 things in our known world that we can sense. And I could be wrong, so I put that question. So forces are they're physical things. Air can convey forces. You can have hurricane or see hurricane. Winds, if you hear me speaking, it's because my vocal cords are causing the air that's in my mouth to vibrate the air that's outside of my mouth. And those vibrations are hitting your eardrum, and you're interpreting that. We'll go into how the ear works in a little bit. But forces can be pressure, could be weight, could be vibrations. Electromagnetic energy. I'm guessing all of you have had this, even though you're in computer science, it's probably been a little while. But the electromagnetic spectrum being what our eyes can see, being how our cell phones work, being how we get images of X-rays of what's going on inside of our bodies, being what's emitted when there's a nuclear explosion of different frequencies, obviously, but the electromagnetic energy, biochemical interactions, thermal energy. Everything has thermal energy unless it has 0 temperature, and I'm not aware of anything that actually has absolute 0 temperature, although vacuum doesn't have much in it, so it's pretty close to true vacuum. It doesn't have a temperature. Electrical energy, these are like electricity that's coming out there on the wall, or electricity that's making things around this operate. So I'm going to make the statement that those are the only 5 things. Anybody disagree with me? If you think it's something letter, put it in piazza. Yeah.
How would you classify
Interoception, I'm going to classify that primarily as biochemical interactions and electrical energy. Most of what happens in your body has something to do with one of those 2 things. It could be force as well. Like if you have heart, like a gas, you can feel. And actually, you're going to see, even in things like hearing, in hearing, forces, there are forces, biochemical interactions, and electrical energy that combine so that you can hear. So those are so reality, the entire existence as we know it, and maybe there's some theoretical physicists that's going to talk about antimatter and black holes and things like that. I'm not going to go there right now because they're too far away. But in terms of our existence as we know it, those are the things that we can sense. So our ability to make sense of the world as it exists are based on our ability to sense or measure one or more of those 5 things. Forces, touch is a force. We feel pressure or weight upon us. Hearing, I already talked about, is vibrating air. You want to silence someone, put them in space because there's no sound in vacuum because there's nothing to, there's no medium for the sound propagating. And then interoception, we talked about if your bladder feels full, there's a combination of things going on. Electromagnetic energy. I put sight there. You could argue maybe that if you're out in the sun and your eyes are closed, you can feel the warmth in your body, so you're absorbing electromagnetic energy. Certainly if someone puts a very powerful laser on your skin, you're going to feel it, which means you're going to sense it. So arguably, touch could be there as well. Biochemical interactions, virtually everything at some level gets into a biochemical interaction, but taste and smell are 2 of the more popular ones. That's why the biochemistry of what we taste is important. Thermal energy, touch or interoception, and that's just literally warmth. When you touch something that's hot, it's different than if you touch something that's at the same temperature as your skin. Even though it's imparting the same amount of force, you're going to feel it differently. And then electrical energy, which you can touch, obviously, and feel, which you typically want to do. If you've ever taken a battery and put it up against your tongue, which I also don't recommend, but you can actually taste that. You can do that with a 9-volt. It's relatively safe. Has anybody ever done that? You can actually taste. You might even remember what that tastes like. And that's the electrical energy that's coming off from the battery. It's not that you necessarily taste it, the metal of the battery. Okay, so those are the things that are sensible, and I've mapped on there different ways in which we can sense some of these things. Now we're going to go through sensing generally, and we're going to come back to each one of these senses because they're really important to understand. When we do come back to these senses, we're going to look at how humans sense, and we're going to look at how computers sense. So we'll go through that with sound. If we have time today, if not, we'll start there on Wednesday. We'll go through that with sight, we'll go through that with touch, we'll go through that with smell, taste, and interoception. So, but now I'm going to go through each one of those 6 senses just at a high level so we can understand what we're sensing and what we're not. So sound is the first part. In sound, it's vibrational forces that we're sensing. We tend to live in air, so it tends to be vibrational forces of moving air, although if we go into the water, we can also hear. Water conducts vibrational sound differently, so we hear a little differently when we're in the water. We hear a very small fraction of the sonic spectrum. So you can think of a sonic spectrum similar to electromagnetic spectrum in the sense that there's a velocity of sound in air, just like there's a velocity of electromagnetic energy in air or in vacuum. Unlike electromagnetic energy, the velocity of sound in a vacuum is a nonsensical question because there is no sound in the vacuum. Don't forget that. If you want to hear a question, it comes up somewhere. There's no sound in the vacuum. Humans can hear sound in the frequency range 20 hertz. 20 hertz, if you're not familiar with hertz, it means 20 times per second. So molecules that are heading your way are oscillating back and forth 20 times per second. When they hit the little eardrum in your ear, it causes oscillations at that frequency. I can't hear 20 hertz. Some of you might be able to hear 20 hertz. We can go all the way up to 20 kilohertz. I can hear pretty close to 20 kilohertz. It is not a pleasant sound, but I can do it. Can you go further? You can, and because of that, we have things like medical tools like ultrasound. You can see a baby inside of someone before they're born, because sound propagates, and there are sensors that can detect that, even though you can't hear it. Some animals can. The upper range of a bat is somewhere in the 70 kilohertz range, so it's way above what we can actually hear. I don't know how they got the grasshopper, but it's around 7 kilohertz. Mosquitoes, 1.5 kilohertz. So you can hear a mosquito. This is not what the mosquito can hear. I'm just telling you, when you hear a mosquito, you're hearing a sound that's around 1.5 kilohertz. When you hear a bumblebee, you're hearing a sound that's around 150 hertz. And that's not so much the wings, actually, it's kind of like the muscles that are vibrating 150 times per second, which cause that sound that you hear. So we can hear things here, and this is a magnitude scale. So 20 hertz all the way up to around 20 kilohertz. But we can't hear things that are at 100 kilohertz, or that are 1 megahertz, or that are 10 megahertz. Or that are gigahertz. If you think about it, even at our maximum, even if we could all hear at 20 kilohertz, that's still less than 1% of the available vibrational spectrum that goes all the way up to 5 kilohertz. Now, it turns out that in air, if I were speaking to you at a really high-pitched voice, which is what 5 gigahertz would sound like, it wouldn't actually get to you anyway. So even if you could actually hear 5 gigahertz, the reason it wouldn't get to you is because the molecules would be trying to move so fast that there actually isn't the space between the molecules at that speed is big enough that they don't get to actually hit each other very well. So there's an upper limit to the frequency that sound can propagate in air. That goes away if you're in a solid, or if you're in a liquid, because they're more dense, because they're a closer path. So you can propagate sounds at even higher frequencies than you can in air. Okay. So even if you could hear really well, just like our electromagnetic spectrum is absorbed by our atmosphere, in this case, the air itself would absorb sounds that are above a certain frequency. So the whole point of this is our reality, as far as we hear our reality, is based on listening to, when we pay attention, a very small part of all the sounds that are actually going on around us. So if we could hear effectively less than 20 hertz, or if we could hear effectively more than 20 kilohertz, we would hear a lot more stuff going on. Okay? But right now, if we just silence everything between 20 hertz and 20 kilohertz, we'll just think there's total silence, even though there's not. It gets worse when you go into the electromagnetic spectrum. So electromagnetic spectrum, or light as we know it, is literally that little sliver there in the spectrum. And we make use of a good part of this spectrum. We talked about nuclear explosions. If there are nuclear explosions, there are transitions that are happening when you blow apart atoms that cause wavelengths that are really, really small. Small wavelengths in the electromagnetic spectrum mean very, very high energy, very high vibrational frequencies. That's what a gamma ray is generated like that. We talked about X-rays. That allow the electromagnetic radiation to go into your body. If you were a superhero, you might think that X-ray vision might be useful for you, but it might not be, because actually, as it turns out, there's not really a lot of X-rays bouncing around things, so you might have to create X-ray lights to emit X-rays so that you can see those X-rays. So even if you could see X-rays, it would be comparable to our world being dark. So you could see X-rays when they were there, but there just aren't a lot of X-rays bouncing around, which is a good thing. Radio, we use it all the time, but we can't see it. But you can actually make glasses that help you see radio waves. And you can make glasses that help you see infrared, which allows you to see objects that are emitting infrared radiation. Okay. So again, the whole point of this is huge spectrum. As amazing as humans think that we are in our ability to navigate the world because we can see, we see a really, really small part of it. So when we make an artificially intelligent being, do we want to limit them to the same little sliver of electromagnetic energy that we see? Or do we want to make use of energy outside of that spectrum? Maybe make them a little bit smarter than that. Some of the self-driving cars that you may hear about do that very thing. They use energy outside of the spectrum to help the car's processor see better and see at a further distance. Sometimes you can use active systems like radar, so you can emit energy and look at it, how it bounces back, so you can see basically in the dark better at these other frequencies. Touch. It's a lot of things, and if you start really thinking about how we touch, it gets complicated. With sound and vision, in some respects, it's a lot simpler. We see through our eyes. If we close our eyes, we tend not to see a lot. With our hearing, the same. If we cover our ears very effectively, we tend not to hear things coming from the outside. How do you turn off the touch? And it turns out when you start thinking about touch, it's pretty complicated. Because you can actually feel someone, even if they don't touch you, because your hearers can actually feel things that even when they don't touch you. Your ear can feel the environment around it. And if someone even just gets close to you, you can arguably feel that they're close to you. I don't know if you've ever had that sense of, I feel like someone's close to me. And they don't even need to touch your hearers, because your hearers are sensing the environment around them. And if that person changes the environment that's around the hair, that can cause a local sensitivity to that. So this is just different types of touch that we have. One is hair and feathers on one end. On the other hand, here's the hammer, which of us really want to feel. So a lot of research in terms of different ways of touching. And in fact, when you start thinking about an artificially intelligent being that's physically interacting with you, I would suggest to you that when you think about touch, it gets complicated really fast compared to when you think about vision. Because you have to think about the fact that, at least from a human perspective, our sense of touch is fairly well distributed and it's very, very diverse compared to our other senses. And that's an important point. All these points are very, compared to our other senses, it's diverse. Our touch organs are all the way up throughout our body on the outside, and then interoception means we have some in the inside as well. Whereas our tongue, our taste is generally here, at a time. And what we smell is generally here. What we see is here. What we hear is here. But touch is fairly well distributed. Just like in sight and in sound, we're fairly limited to what we can actually sense through touch. What's the lightest thing that you can feel? Or what's the lightest thing that you can feel the weight of? Is a better question. Chicken feather, on average, apparently weighs 1,0003 ounces. I don't know if you would feel the weight of a chicken feather. You would feel probably that it would tickle, maybe because of some of those other touch sensors if it was moving around. Moving that up on a scale, a strong hurricane, I think this corresponds to somewhere between 175. Category 5 hurricane, according to scientists, exhibits about 1,600 ounces of force per square foot. You would definitely feel that. Strongest human ever recorded apparently lifted 18,480 ounces. So for me, 18,480 ounces would feel as heavy as an empty 747 because I can't pick up anything. So as far as I'm concerned, they both make the same. The movable objects to me. That turns out to be something I think like 1,100 pounds. It's quite a bit. An empty 747 jet, 6 million ounces. And then the Earth, apparently, I don't know how, but the Earth weighs that much. Okay, so there are things that weigh a lot, and our ability to distinguish them, at least for me, is pretty much limited to somewhere between, maybe 7,500 pounds to some fractions of ounces. So pretty small. That's just looking at weight. We're going to go to taste. Now, the average person has about 10,000 taste buds, and a catfish has 100,000 taste buds all over their body. So we talked about in humans a little while ago that we taste mostly here in our tongues, in this area here. But a catfish actually can taste because its taste organs are distributed along its body. Apparently the reason for this in part is because they like to hang out in the bottom of the riverbeds, and there's a lot of mud that swirls around. So if they want to navigate that for things that they want to eat, it's really hard for them to see anything, especially in dark environments where there's not a lot of light to begin with. So they have a heightened sense of taste. The reason chickens eat worms is because they only have 24 taste buds. As it turns out, chances are you have a lot more taste buds than I do, because as you get older, you tend to lose taste buds. So as you get older, you're going to realize that vegetable didn't taste as bad as I remember. Well, it's because it tastes different now, because you have less taste buds. So sometimes less taste buds is good. Smell. Sometimes worse smell is the ability to not smell very good can also be good. Smell, again, humans smell a very minuscule fraction of what's actually around them. And you may know this also, that we have a dynamic sense of smell. It's not written here. What that means is, and it resets. So you can walk into a room, smell something, and then your brain actually will help you begin to filter that smell out. So even though the smell is still there, if someone new comes into the room and smell it, chances are you're not smelling that anymore, even if there are some interactions going on in your nose. And it's probably a good thing. If I could had a heightened sense of smell, presumably I could smell all of you, or the combination of all of you, as if I was very, very close to you. That's what a dog can A dog's sense of smell is between 1,000 and 100,000 times more sensitive than a human. So we're not here to become experts on how dogs smell. And the reason I'm painfully going through all this is so that we really do understand just how small, how little of the world we actually sense when we form our reality. I think we do a pretty good job of forming a reality that's pretty close to what actually exists around us. But we do it with a very small amount of information from all the information that's available around us. Interoception, again, we'll go through all these senses again in more detail. It's a lesser known subjective sense. And it's subjective in the sense that you can see things and you can take a picture of that, what you saw, and show it to different people, and you can have them agree if they can see the same thing. Or if the picture represents what they saw with their eyes, for example. You can record things and do the same thing. Say, okay, this is what was going on in the world. Now I'm going to create a representation of that. You all agree that they're saying the same thing. When you get to interoception, it becomes a lot more difficult because these are things that are going on inside the body. So we can talk about it and say, well, I feel a stomach ache. And we think we know what a stomach ache feels like, but it becomes harder to know what it actually feels like to you. And there's a lot of things that we get from our interoceptors. So it is personal. We get pain, we get hunger, pleasure, we get feelings of fullness. If we're thirsty, not everybody, by the way, has all of these. So some people can't feel pain, or they don't know when they're hungry. Discomfort, feeling of tiredness, a headache. Whether I have to go to the bathroom, itching. Some people, you may know this, that have their legs amputated can actually feel itching in their legs even though they don't have their legs. So those are things that are coming from inside of you. And heart rate. These are some of the tools that you don't need to know this now. These are some of the ways that science goes about trying to make these subjective things more scientific and being able to compare them from person to person, which is the level of attention that you get, detection, magnitude, discrimination, accuracy, and self-reporting in terms of having people describe what they are feeling inside when they're experiencing something. We're definitely not going to get the sound, by the way. Okay, so our perceptions of reality are heavily influenced by our senses. We have senses in common with other animals, but animal senses are different. Okay, so if you ever want to know, is your dog, if you have dogs, I happen to like dogs, but I know everybody doesn't. But if your dog sees the world the same way you do, they don't. They don't, right? And when I say see, I mean perceive, sorry. This is an elephant, and an elephant can smell water 12 miles away. I don't know how they do this experiment. I'm guessing they put water somewhere 12 miles away and see if the elephant finds it. But an elephant, and it kind of makes sense that they would have some smelling superpower here going on. Okay, so certainly in terms of smelling water, an elephant has some ability that we don't. A platypus apparently can sense the electrical impulses of their prey. If some of you might be aware of brain computer interfaces, that's not a term that you've heard. It's pretty cool. Basically, it's mind control. So you can put a device on your head that senses the electrical signals that are coming out of your head. And you can use that to control things. It's actually something that's pretty cool. It just started fairly recently. It's called a drone race. And so they have like a little obstacle course. And it's literally a competition where you put this thing on and you think your way to try to win this race. And depending on what you think, changes the pattern of electrical signals that are coming out of your head, and that allows you to control a video game, essentially. Okay. So platypus could actually potentially sense you, because you, like other animals, emit electrical signals, and if you were in water, you would emit those, and the platypus could presumably know you're there. If you see a snake and you're trying to hide from it, you saw Harry Potter probably. Turning off the light is not going to help you. Okay, and that's because many snakes can actually see the thermal radiation that's coming from you. What does that mean? That means that if you could see, just like you see, but you could see a little bit outside of the spectrum into the infrared part of the spectrum, which is just, you could almost see that part of the spectrum, so it's not way out there like a gamma ray or an X-ray. If you could just see a little bit more, you could actually see people in the dark, because the body temperatures of people cause them to emit energy. So you're constantly emitting energy, even if you're not doing anything, because you have a temperature and you emit light, basically, but at a frequency you can't see. But a snake can see it. Apparently, if you're an octopus, you can control the intensity of light that's incident upon your eyes. Okay. I do that by putting on sunglasses. Okay, but presumably, if you're an octopus, you have some ability to sort of vary the intensity of the light that's getting to you. And I actually got really interested in this while I was putting this presentation together. Spent some time reading on here. Apparently, these particular beetles only breed in burned trees. So it's not surprising they have ability to find trees that are burned, even that are very far away. You may have heard this. Bees can sense magnetic fields, so they can actually sense the Earth's magnetic field. We already saw some cases where the organs that taste are outside. That was the catfish. Spider apparently not only can smell, but can also taste with its organs that are on the outside. So it'd sort of be like taking your nose and flipping it and having that all throughout your body. So you'd be smelling thoroughly everywhere. And then a bat uses echolocation, which means they actually make these high-pitched sounds that travel and bounce, and then they hear those, and that helps them maneuver. So that's an example of an active scenario. Okay, so next up is going to be real and artificial human senses. I was hoping I could get to this today. That's not really going to happen because we started a little bit late. But maybe I'll at least put on the video. It's 3 minutes long. And then we can end right after the video. I'm not going to put on the speaker because I'll just take more time.
Ears are constantly active. They pick up sound waves and change them into information that the brain can interpret, such as music or speech. Sound is a pressure wave that can vibrate either quickly or slowly. Slow vibrations produce deep sounds, while quick vibrations produce high-pitched sounds. Sound enters the ear and is directed through the ear canal, where it first reaches the eardrum. As the eardrum begins to vibrate, it sets the ossicular chain in motion. The ossicular chain consists of the hammer, anvil, and the stirrup. Sound vibrations move along the ossicular chain and into the inner ear. Within the inner ear, the cochlea plays a central role. It is here that the mechanical energy of sound is converted into complex electrical signals, which are then passed on to the brain. In simplified terms, the cochlea is a spiral-shaped tube filled with fluid. Sensory cells, also called hair cells, line the entire length of the cochlea. These hair cells have varying degrees of sensitivity for the detection of different tones or frequencies. This allows the ear to perceive the entire spectrum of sound. The change from mechanical vibration to electrical pulse is a complex process resulting from the movement of hair cells in the cochlea. Along the entire length of the cochlea, the hair cells are arranged like the keys of a piano. Hair cells located at the base or lower region of the cochlea are responsible for high frequency, while hair cells at the apex are responsible for the low frequencies. As the fluid in the cochlea is set in motion, it causes a corresponding movement of the fine structures on the surface of the hair cells to take place. These movements cause tension differences, which produce electrical signals that are passed along the hearing nerve to the brain. The auditory cortex of the brain interprets this information as sound, for example, as music or speech. The entire chain of events, including the various steps that convert sound waves from the environment into information that the brain can interpret, happens so fast that individuals can hear sound both continuously and instantaneously.
I'm going to pause it there. I think we're going to get to perception. And it's hard to separate those two things out. We're going to actually go back through all of these senses again and talk about perception. We're not going to do that now. But I want to make sure that you understand how we're building as we go along. Because remember last time that we all heard a sound, but some of us heard bar, 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 and some of us heard far, far, far. If you just take this simplistic model, it doesn't explain that, right? Because you've got these electrical signals that are just interpreting what we hear, right? But they're saying, okay, well, instantaneously you hear, right? So, but you can already start to see that from that example, it's good that you are, it's just we're not going to go into perception just quite yet. We'll do that in a few weeks. That at some point, these signals that are coming from the sound are going to be interpreted together with signals that are coming from other places. And it's not just from your eyes. As we get through reading more of Feldman's book and how emotions are made, you may actually start to believe that depending on how emotional you are, okay, not just how someone's lips are moving, but depending upon how emotional you are, someone could actually say something and you would swear, if you did such a thing, that they said something else. All right, remember next class is going to be virtual, but it's not going to be any less